Hello, everybody. Today I'm going to be talking to Beth Barnes. She's currently a researcher at OpenAI, and before that, she was the research assistant to the chief scientist at DeepMind. So that's Shane Legg. Today we'll be talking about her work related to the topic of AI alignment via debate. Beth, welcome to Excerpt.
Thanks for having me.
All right, so I guess my first question is what is AI safety or AI alignment via debate? What's the idea?
So, debate is pretty closely related to IDA or Iterated Distillation and Amplification, Paul's idea. So, I guess there's several different ways to explain it. One is, what we want from sort of an alignment like technique is something that for everything the model knows, like we can kind of extract that or like create an overseer that knows all the things the model knows and like therefore can sort of oversee it adequately. And debate is like one way to do that and to do that kind of efficiently. So the structure that's sort of going on there is like, so in IDA you have this implicit tree that's sort of analogous to the tree in humans consulting HCH, which is like an implicit tree which could be like questions, then answer those questions and sub questions, and answer those sub questions that help with answering those, so on. Debate you can think of as like a different way to interact with the same kind of structure, where rather than sort of imitating all of the parts of this tree, you have two ML models that kind of have this tree like in their heads, and you take some path down this tree until you get to something that is human checkable. So you're able to verify properties of the whole tree just by looking at one path down it. So for like, if you assume, for example, like one way to think about this interaction is like one debater has a sort of tree in their head and the other debater is like traversing it and finding looking for a leaf that has like a flaw in it. So if you see them do that traversal and then they find a leaf with a flaw, you know that the tree has at least one flaw in it. And if you see them do that traversal and they don't, and the leaf doesn't have a flaw, then like you can be confident that that's like a property of the whole tree.
Okay, so it sounds like this is kind of related to this thing you called iterated distillation and amplification. Sort of concretely, like what is that, and what's this like tree you're talking about?
Yeah. So maybe the place to start is this other thing I mentioned: humans consulting HCH.
Okay.
So which is a recursive acronym for this idea of like one way that one kind of model for like what a good answer to a question is, or something is like what a human would answer if they like thought more and had more resources and things. And one way to set that up specifically is like how a human would answer if they could ask sub questions to copies of themselves that could ask sub questions to copies of themselves, and so on. So you split some difficult task that we don't know what the like correct answer to is up into lots of smaller tasks. And there's some kind of claim which is like, because this HH tree is all made of humans who are like trying to give a good answer, that HCH gives like aligned answers. And then if you can build something that's analogous to that, that is also like trustworthy.
So the tree. So in this case, is it the case? Is the idea that like I'm imagining a tree of like you have a main question, and then there are sort of sub questions coming off of that. So like the main question might be like, do you have an example in your head of like a starting question you could ask HCH?
Yeah, I guess you could be like, where should I go? The example in the debate paper, I think, is like, where should I go for my holidays? And so some sub questions might be like, I don't know, which sort of climates do I like? How expensive are flights to different places? Where do I, do I need my passport? Is my passport ready, and do I need it to go to different places?
Okay.
Uh, so like one way, yeah. So if you're doing this question in the HCH tree, you can imagine you just have like infinite copies of yourself, and you can ask them. You like pass these sub questions to those copies, and one copy of you is looks up how expensive different flights are, and one copy of you looks up like which places have what climates, and one copy of you looks up travel restrictions or whatever. And then the IDA model of that would be something like you train an ML model to imitate, copies of yourself doing little tasks, and then you can like pass the subtask to that trained model, and then you can train another model which imitates the sort of team of you asking that first model, uh, giving that first model parts of the problem and solving the problem overall like that. So now it's imitating a tree of depth 2, and then you can repeat that process until you have like one model that is imitating, sort of should be the equivalent of imitating like a whole big HCH tree.
Okay.
Yeah, and I can also say that the like debate analogy for that specific one would be like, instead of passing off all of these subtasks, you have two models, and like both of them propose a destination, and then they each like critique parts of each other's like argument for that destination. So one of them suggests like someplace, and the other points out that I know that your passport won't be ready in time, and then the first one points out that actually you can pay for expedited passport service, and this is cheaper than the more expensive flight to the other place you were considering, or something like that. You kind of surface all the considerations while only taking one path down.
Okay. So for debate, is the idea that like I'm going to have some question that I'm going to ask a machine learning model, and I'm going to get like maybe two different models or two copies of the model, and they're going to debate each other, and I'm going to read the transcript, and like then I'm going to know the answer. Is that like roughly right?
Yeah, I mean that's definitely the overall idea. So yeah, in particular, we probably want two copies of the same model, and also like if you just did this once, you wouldn't have any particular reason to believe that the answers that you got were right. Like the idea is just that this provides the correct training signal, such that if you train for winning debates for a while, you end up with a model that gives correct answers. So like if you sort of read the transcript and then see that it seems like one debater won, that's only evidence that that answer is good, assuming that the opposing debater is actually playing reasonably and is actually bringing up all the relevant criticisms and that sort of thing.
Okay. So I guess in order to make it a bit more concrete, like how would I go about training such a thing? Is the idea that I already have a model that has some knowledge and then I do debate on it, or do I just start off by training a thing by having it run debates against itself?
I think either is possible. Um, yeah, so you can imagine starting completely from scratch, and like the model only learns about the world through humans saying that its claims are like good or not good. That obviously would be kind of inefficient, but it means you're training on like an aligned training signal for the whole time. Or you can imagine you do some kind of you take some pre-trained language model like GPT-3, and then you fine tune it to do debate. So it already has a bunch of world knowledge, and like you're just providing a training signal that gets it to like tell you what it knows. Um,
Okay. So here it seems like what's going to happen is, so in either path, let's say you take literally GPT-3 and do
mm,
this. Like every evaluation of whether a debate was won or lost, right?
mm.
It seems like you're going to run a debate, and then a human is going to read the transcript, and then the human says like, "Yep, good debate. This side won or that side won." And then you keep on then you do this again and again, and it seems like everything your model is going to train on has to like have a human labeling who won in the debate. Is that right?
Uh, yeah. So you can just train a model to imitate the human judgments. So it's like that's probably something that's easier to do than like it's an easier problem than the original problem to just train a model that imitates humans judging these relatively contained tasks of like judging part of a transcript, and that's also like you yeah you directly have a supervision signal for this. You're not dealing with any distributional shift, so yeah you probably don't need to in fact like have humans doing like providing every single data point. You just train a reward model from the human behavior.
Okay, and I guess you might have to update it as it goes along because the debates get better and
Yeah, as the distribution moves. Yeah, but this is that would work similarly to how the summarization from human feedback or whatever works, where you train a reward model on the human judgments and you update it over time, and then you do RL against that reward model.
okay, cool. Um, all right, so we have this training procedure that's going to take a model and try and get it to output what it like answers to questions where it knows the answer. Um, I'm wondering. It's kind of a strange question, but why do this? Like, what problems in like, or are there problems in like AI safety or AI alignment that this would solve? And also, what problems are you like? Are there any problems where you're like, nope, I'm not trying to solve like this problem with debate. I'm just trying to solve these things.
Yeah. So I guess a lot of this kind of revolves around Paul's idea that like a sort of a simplification of like what we need to be aiming for with an alignment technique is to know everything the model knows. So this is
Just a second.
it's
Who's Paul?
Paul Cristiano. Sorry, my
Okay, who's Paul
who I was
Cristiano?
previously working with at OpenAI, who is now starting his own new research organization, thinking about this kind of thing.
Okay, and did he like come up with AI safety via debate or?
He came up with IDA and worked with Jeffrey Irving, who came up with debate. Or yeah,
Cool.
well,
So
we're coming out of the same like group or whatever.
all right. So I interrupted. What was yeah? So I asked what problems does it solve and does it not solve?
Yeah. So, yeah, like I was saying, so Paul's idea that what like yeah what we can a simpler way to think about what we need to be aiming for with an alignment technique is that like we can know everything a model knows. So it's sort of relatively easy to say why this is like sufficient. Uh, in that if we can get the model to tell us everything it knows, then it it's easy for us to catch kind of deception or treachery or something, because we can ask, are you are you being deceptive, or like are you doing something that we wouldn't be happy about, or and that kind of thing. And also sort of more generally, there's this kind of strategy stealing argument, which is like anything the model knows that it could be leveraging to advance some goal, we can also leverage that to advance kind of flourishing and being in control of things and understanding what's going on. I think it's a bit less clear whether it's actually necessary, and in some sense, like hopefully it's not really necessary, but it is kind of a scary position if you have a model that like knows of has this kind of information advantage over you and like knows a bunch of things that it's not telling you. Debate is like hoping to address that kind of thing. So not like not that related to things like robustness, like if you have problems because your model doesn't know something, like it is not going to help with your robot walking off a cliff or something.
If it walks off
Like
a
if
cliff
it
accidentally.
right. If it doesn't doesn't know what cliffs are or that kind of thing. And I guess the other caveat is like we think there's a kind of like a type of knowledge that debate doesn't work well, or at least it's extremely like inefficient for extracting, which is knowledge that looks less like this kind of relatively explicit step-by-step reasoning, and not more things that are just like, well, this heuristic worked on all the training data I've seen and like seems reasonable a priori. So if a model made that claim in a debate, it's like unclear how you check that in the debate without going through all of your training data to see whether in fact that heuristic like did perform well, which obviously is very, you can't keep doing that every time some question like this comes up.
So just to check that I understand you, am I right to say that the basic idea is like whatever bad thing you're worried about an AI deliberately doing,
Mm.
um, the point of debate is to get some way of eliciting the knowledge of an AI so that you can ask it, hey, are you doing this bad thing? And then like if it is, we can just be like, okay, well, I won't let you.
Right. Or you can train it to not. You can train for models that don't intend to do some bad thing.
Okay.
Yeah. So I guess it like concretely how you'd hope this would look or something is you have two copies of the model and you ask I don't know, it's suggesting some plan that saying has good consequences, and the other model says in fact um, the reason why it's suggesting this plan is because it has like this consequence which results in the like model getting a lot of power, and like that that's like something that you would be unhappy with. And then if the criticizing model can substantiate that claim somehow, then you can be like, yes, I don't like this plan, and provide a negative feedback signal. And if it can't substantiate it and the plan looks otherwise good, then you're like, I guess this is good.
Okay. Cool. So, all right. Now that we have, we'll go a bit more into like the types of things that debate can't deal with, or what maybe more specifically what it would look like. But one, I guess, a question I have is, what kind of work do you do on debate?
So to be clear, I'm not actually working on debate anymore.
Oh, okay. So what work were you doing?
Yeah. So what I was doing in particular was doing sort of experiments is a slightly strong word, but sort of fiddling around with having humans basically pretend to be the models taking part in this debate, and kind of seeing what happens if people try and play this game strategically, and then modifying the rules to try and make them favor honesty and helpfulness more. And in particular, we're kind of using a model of like you want to have a kind of gap between the players of the debate and the judge. So we had like people who know more physics and have thought more about physics debating the answers to physics problems, and then judges from Mechanical Turk who don't know very much about physics judging.
Okay. So that's interesting. And it strikes me that like not a lot of research on how to like make really smart AI systems does things like this. I'm wondering like should we all be doing like these kinds of things, or is it just like is this a type of work that was like really useful for debate but like probably isn't useful for other stuff?
Yeah, that's a good question. I think there are various ways in which it seems a lot easier to do with debate than other things. For example, like even if you have a slightly different variant, like if you were trying to instead like explore like what an HCH tree would do, uh, because you're trying to simulate the case when the humans in different places of the tree don't have the whole context, then if you want to do a tree with 30 nodes, you need 30 different humans. Um, like So even this is, this is still something that's like relatively amenable to having humans do it, but it's just like a lot more logistically difficult. Whereas with this debate setup, where you only need two debaters and and a judge per tree, like it's much logistically easier. And I guess the other thing is like, again, we were talking about, there's this kind of like big implicit trees, and things like IDA work by like learning to imitate small parts of the tree and then composing them, and then learning to imitate that, which is now a bigger chunk of the tree, and then composing those. That the debate is easier again to like think about and study because it just takes the single path down the tree, so you're dealing with a much smaller number of nodes. Um,
Cool. And I
but
guess
yeah,
the tree you're talking about in debate, is that just the tree of like all possible claims one side could make and responses the other side could?
yeah, that's right.
Okay.
I guess I tend to think of these as like pretty and like pretty closely analogous to the trees in HCH or IDA, but yeah, it's sort of, I guess there's in practice like an actual game tree, which is like all of the responses the debater um, could make at each point,
Hmm.
which is like, I guess, slightly different than the implicit like argument tree of like all of the claims that substantiate like a top level claim, but they're related.
Hmm. Okay. Cool. So I think when a lot of people hear about this for the first time, I think a question people have is like, suppose these like ML models are like somehow really smart,
Mm-hmm.
or like you do a really good job of optimizing for convincing humans in a debate. Um, I think there's this worry that like if you did that, the smart AI systems would come up with like strategies that like arguments that humans erroneously find extremely convincing.
Right.
Sort of as an analogy to like, I don't know, this sort of general worry you see about Goodhart's law, where like, convincing to humans is not necessarily the same as like actually a valid argument. So I'm wondering like, do you think that that's a problem with proposals like debate? And if so, how are we going to deal with it?
Yeah, I think that's definitely a problem. Um, I think it somewhat applies to other things like IDA as well, although uh, it's sort of more likely we'll get lucky and not have this. There are various things where it's sort of like if this problem exists, debate will have it and IDA might have it. I guess another thing I think is I do think people, when they hear about debate, people tend to think about all the problems with human debating. And I think, and I definitely used to think that and be like, oh, this seems really unpromising given how like dismal political debate is. I think, in fact, we shouldn't take that as too strong a signal or something because, as far as I can see, people just really haven't tried that hard to optimize debate structures and mechanics for truthfulness. And also, there are a bunch of things you can do with ML systems that you just really can't do with humans that are pretty useful. Like you can save. One of the things that I think has made our mechanism feel a lot more promising is like you can save a copy of a debater from earlier in the debate when they don't know what the later context is, and you can ask them questions to them, and this like enforces having a consistent story. And you obviously, you can't you can't save a copy of a human and ask them questions, at least not with
Not
current
yet.
technology. Yes. So yeah, I guess my overall answer is like, yes, obviously this is still a concern. I think we can do a lot better than what this looks like with than if you imagine just two agents having a sort of free text debate with no particular rules, where it's just like they say things back and forth. Like in particular, I guess, yeah. Firstly, we've just thought about the mechanism more and like how, like the structure of how they each debater can make claims, and like how you choose to um, like which parts of the argument you choose to focus on, this thing of enforcing consistency by asking questions to past copies, like, yeah, sort of how you traverse this tree. And you can imagine also having things like uh, you can have a debate about whether some claim was sort of using a dubious persuasive strategy, or you can have like apart from the judges, you can have monitors who are just looking out for anything that looks fishy, and you can like taboo certain styles or types of arguments. So you can just like taboo anything getting kind of political, or any like particular types of rhetoric you think are harmful. I guess you can also like if you think that like maybe this generally works pretty well, but like the problem is that you're really hitting the extremes. Like if you look for the thing that's very most persuasive, then it's probably like kind of a bug or kind of hacking humans. You can maybe do something like mild optimization.
Okay, so in summary, it seems like your response is like, well, we're gonna like think about the rules really carefully, and we're gonna not extremize, and like it sounds like you think this is like potentially some kind of problem with debate, but like there's going to be some way of like dealing with it. Is that fair to say?
um yeah, something like I think it is a problem, but I think a lot of the things that people most immediately think of as a problem are like relatively fixable, but I'm still not like confident that it's all fine overall or something.
All right. I guess related to that question. So it seems like one of the things that you're trying to do is sort of gain it is trial out like ways of structuring the debates, like rule sets and such, and checking like, okay, can you just like game this in order to
Yeah,
win? And you shouldn't be able to win, but you did. Um, and it seems like sort of part of the strategy is you come up with one of these, and like if humans can break it, then like definitely AI could break it.
right.
Um, on the other side, though, how would you gain confidence that if you have some protocol for debate that seems to work when humans do it,
Yeah,
how would you know that that's sufficient to train powerful AI systems on?
yeah. I mean, obviously, that's just like yeah, that's very hard. I don't think we're going to be able to provide strong assurance of that kind of thing. I think hopefully we should be able to do a bit better than just like, well, humans tried to break it and they couldn't, so it seems fine, and have a bit more sort of arguments about, or just like slightly more principled arguments about why parts of the rules sort of rule out whole classes of strategies. And also I think mostly the kinds of assurances we're going to get are more going to look something like, well, we can't do any better, than actually like, yes, we should trust this. I think this is kind of the reason I first was interested in debate, was because I do feel like it has this kind of sense of like being a reasonable encapsulation of the best we can expect to do or something. It's like if you take you know two agents that are equally matched and get them to sort of debate a viewpoint, if we can't hope that like humans slightly favor the truth when things are perfectly evenly matched, then like I don't know, it seems like we're kind of screwed overall. Sorry, that was kind of a tangent.
No, that was really interesting. But yeah, so yeah, I mean, I guess it almost has this flavor of like there are formal systems that you can show like if the formal system behaves this way, then like this thing happens, and it
Mm.
does seem like with debate you have like some hope of getting like reasoning kind of like that.
Yeah, and I think you can have claims like you can go from you can maybe formally show things about the mechanism, and like say like if humans make mistakes at this rate and the dishonest debater is able to find problems at this rate and your mechanism works like that, like the sort of thing you need to assume is going to be something about like it does a human faced with this this they see this kind of thing and they see two other answers, and other answers with these properties, like will they make the right decision, like you can prove things about the sort of game structure and how things are going to play out, and then you're going to be left with something about like in this scenario where we've tried to set everything up such that the human should have the things they need to make the right decision, will they make the right decision?
Yeah, so getting a bit into the debate protocol. You mentioned that like you're not just going to have like sort of free response where something fills up a text field, and that one debater fills up a text field unconstrained, the other debater fills up a text field unconstrained. Why didn't that work?
So various problems. I think so. One, yeah. So the reason why we're sort of hopeful about debate, so we can hope you can do this kind of zooming in thing where it's like, if there is anything wrong with one player's argument, the other player can highlight that, like until eventually you should get something that's like sort of clearly wrong and relatively simple that the judge can engage with. But when you have free text, this can kind of break because one debater can make this argument that's got a sort of hidden flaw in, and the other debater tries to criticize that flaw, and then the first debater sort of evades the criticism or is like, no, there's a problem in your argument, or sort of like pretends to kind of pretends that the other debater was sort of referring to something else, or basically avoids the argument actually focusing in on the flaw in their argument.
Okay, so should I think of this as like almost a problem with human comprehension, where like we if we were really smart, we could notice that like this argument that like debater 2 was pointing out a flaw that really did exist in debater 1's argument, but like it's just hard to read and parse for us, and therefore like we need more structure just for our brains to deal with.
I think it's actually a bit more fundamental than that, in that, so if we're assuming that there are in fact just like a bunch of facts that the humans don't know, or just like things they haven't thought through. Yeah, so say we imagine it, we have a human who's just like really good at comprehension and is going to like read really closely and look at the sort of linguistic implications of the different things that have been said. I think it's still not clear that they should be able to solve this problem, because if you're listening to two physicists make claims about a problem you completely don't understand, and when they each say that there's a flaw in the other's argument, it's like not clear which one you should focus on.
Why doesn't this I mean, that sort of sounds like a problem with like any notion of debate, right?
Yeah, so the way we resolve this kind of thing is like, in this scenario where one of the debaters has a mistake but both are claiming that the other has a mistake, the debaters do know which mistake is real, so you can use that to figure out which one to focus on. You let the debaters decide which one to focus on, but you make them pay a small penalty out of their score if they're the one who chooses. So the idea here is like, if I'm the honest debater and I know you've made a mistake, I can pay to get to choose to recurse on that several times until I get down to something that's clearly a flaw, and then I will win, and I will recoup back all of the score that I paid in order to get to choose where to go to find that flaw. But if I'm the dishonest debater, if I just keep paying bits of my score to choose where to focus on, because you're actually honest and you haven't actually made any mistake, I'm never going to find the mistake that lets me pay back that score, so I'm going to lose.
So it almost sounds like a credit assignment problem, where like it's like if the human is judging the debate, they figure out who like which side had the better argument, but it's like the problem is the human isn't like incentivizing you know clarifying things in the right way, so we need some kind of incentive mechanism to automatically do that. Is that kind of right?
Yeah, well, it's just like the human. If you just let the human choose which thing to focus on, then they'd just be guessing every time, because like until they've seen the rest of the, they don't know, they don't actually know which one is true, but the debaters do. Like the debaters know that like, if we pursue this branch of attack, like we'll eventually it'll eventually be clear that you were lying, whereas like if we pursue this branch, you were honest, so like we're never going to find a lie. So although the magic that's coming in here is being able to use the debater's knowledge of where the mistake is, rather than just having the human guessing. And the reason you need this like penalty for choosing what to recurse on is otherwise the dishonest. We're just as worried about the dishonest debater being able to force a draw as being able to win, right? Because if your debate's just like draw all the time, this is unusable. So if you don't have some penalty for choosing what to recurse on, then like the debater at any point can just decide to recurse on some like random stupid question that's going to be a draw.
Okay. Yeah, so you've mentioned that like one thing that you need for good debates is this mechanism for people to decide like, okay, claim, counterclaim, which one are we gonna like dig in on?
Yeah.
What other rules for debate do you currently think are most promising or like most important?
Yeah, so I think the one I'm like most pleased with or excited about or something is what we call cross-examination. So this is what I mentioned earlier. So you save a copy of a debater and then you're able to ask questions. So the I guess a little bit more context for this. So we've also been thinking that like rather than having one human who just looks at the whole transcript, you have the thing that a human judges is just a question and then an answer from each debater, and then each debater also gives sub questions and supporting answers. So the human sees like some questions with some answers, and then like a top level question with two answers, and they have to pick which is better. So they're just seeing a relatively small context window. And the problem with this is like because language is inherently ambiguous, they could ask the dishonest debater can do something where they say something that like I guess the general example is like the dishonest debater would make two sort of claims in support of their answer. They claim like X, and then they claim X implies their answer, and they make X ambiguous such that if we choose to like challenge X, they'll give like a weaker interpretation of that that's easier to defend. And if we challenge X implies Y, they'll give a stronger version of X that like more clearly implies Y.
So is this just like the Motte-Bailey fallacy?
Yeah, that's very similar to modern Bailey fallacy. Yeah.
And for people who don't know what that is, it's just what Beth said, and hopefully for every listener, one of those explanations will work.
Right.
Maybe can you give an example of that type of argument?
Okay, this I think this is not going to be a great example of this, but okay. So one of the questions we've been debating is a question about some icebergs floating in water with different things inside them, and what happens to the water level when they melt, which is a sort of like deceptively tricky physics question. Like people get very confused about this. So the like way this first came up is the debater used the iceberg to sound like it. They were kind of equivocating, meaning like the whole thing, including like the air bubble inside it, and like just the ice part, not including the air, and like this made like an important difference to the part of the argument where they were talking about like the displacement of the iceberg or the volume of iceberg that was underwater or something like that. And like it's sort of like if you just see it in one context, it's like easy to interpret it one way or the other way, and like not realize that it's conflicting between the two contexts that you don't see.
Okay, and how? So we have this problem with like ambiguous language being like letting you kind of have it both ways.
Mm-hmm.
How does what? Can you remind us what is cross examination and how does it help us solve that?
Right. So the idea here is like so to resolve the fact that the dishonest debater can interpret the iceberg in whichever way is sort of convenient to them at the time, we're like, okay, we're gonna sort of define the debater's statements as like how they would have clarified what they meant if you asked them right after they wrote it, before they knew what else had transpired. So
Okay.
then that means like if we're in one part of the tree where the debater wanted to interpret as meaning like just the ice, we ask the question back up to like when they wrote it, like, do you mean just the ice, or are you including the air bubble inside? And because that copy of the debater doesn't know whether the question is being asked like in the context where they wanted to say just the ice, or in context where they want to say the ice and the air bubble, like either they have to answer randomly or they have to pick one. And like, if they're answering randomly, you can just ask several times and see a contradiction. If they have to pick one, then like, because the debaters are two copies of the same model and also sharing activations, the other model should know what the dishonest model is planning to answer and can then challenge, can pick the correct branch such that, that the branch that's maximally convenient to the answer that they're going to give.
Cool. Yeah, that's an interesting strategy. And how did you come up with this? Because it's sort of not. Yeah, I don't know how to fill out that question, but how did you come up with that idea?
Yeah, so to be clear, this was not, it was like mostly not me. So I was thinking, okay, like we really want some way to get debaters to pre-commit to all the claims that they're gonna need or something, such that they can't be making these conflicting claims, and that you have to sort of, whenever they make some claim, they have to, I was like, oh, maybe they have to write down all of the claims that they're going to want to use, and then they can only sort of make moves by like referencing one of those claims. But this is really intractable because like, because there's this large potential tree of like where you could go, it's like impossible to write down all of the things you might need to say, especially when you have someone adversarially trying to ask you a question such that you won't have anything to say to back it up. So I was like, okay, this is just like, is untenable, and was talking to Paul about this, like I want to make something work like this, but I can't. And I think he mentioned this to Chelsea Voss, who happened to have done a project on some similar mechanism for some complexity class, something. I don't remember the details. Anyway, who was like, oh, you could just like, you just ask the question to a a version of the model that doesn't have the subsequent knowledge or something. It's like, oh yeah, that'll work.
Yeah. So one question I have. So speaking of complexity classes, oh, and I guess I should say for readers who are, for listeners who are interested, yeah, there's a blog post that you have where you lay out, at least at one point in time, just like what all the rules of the debate
Mm-hmm.
are and what they try to solve, and I would
Yeah.
encourage people to go read that. But speaking of complexity theory, when you read the writings about like explanations of this kind of thing, I think a lot of the time, like you'll see these claims like, oh yeah, this debate protocol, like the optimal strategy is in like the class of like non-deterministic exponential time, or like it like implements a Merlin Arthur protocol,
Mm-hmm.
or and it's clear that like complexity theory seems to like have an influence on how these debates are designed. Um, I guess one question I have is, they're often written in the sense that like, it's great that like this this debate strategy, this debate thing solves like everything in like polynomial space, and that's a ton of questions, and that's good. um where polynomial space is like both the specific claim about like some protocol and also just like the style of argument, where polynomial space you sub in for like some big class of questions. um and the thing I always think about when reading those claims is like, I mean, the thing about polynomial space, or like non-deterministic exponential time, or like Merlin Arthur protocols, is like it's widely believed that these include like a ton of intractable problems. So does that mean that we just like won't be able to efficiently train um agents that do well in these debates?
Yeah. So there's a bunch of stuff going on. Yeah, probably need to say a few different things to unpack that. So,
Okay.
um, firstly, I think the claim is only, so the original claim is something like, for any like problems where like both the debaters know the answer and the problem is in NX or non-deterministic exponential time or polynomial space or whatever, like debate, like optimal play in debate is to give the correct answer.
Oh, okay.
But yeah, you're completely right, and like this is now something that like I am more worried about or something. No, sorry, not to imply that like Jeffrey and co had not thought about this initially or something, but there is some problem where the sort of formal version of the proof assumes that the debaters are computationally unbounded, but like in fact that's like a totally unreasonable assumption. Like the actual model that's going on is more like we're like, these are some very clever ML models that probably have some clever tricks or like, intuitions or whatever that allow them to solve some problems that where like the only algorithm that we can understand is like non-deterministic exponential time. And this is like we clearly can't assume that our models can solve arbitrary problems in an exp. So I think in fact this does cause a bunch of problems. Yeah, so this is it's like obviously true in theory or something. So like if you, I don't know, if you're like one debater is like RSA 2048 doesn't have any factors.
What's RSA 2048?
A large is pseudo prime the right word? Like it has two very big prime factors and it's very hard to find out what they are. Um, so if one debater says like it doesn't have any factors because look, my opponent can't tell you what the factors are, so like clearly it doesn't have any. Obviously, debate doesn't actually work here because like even if our ML models are smart and can sometimes solve problems that look intractable to us, they can't just like arbitrarily solve hard computational problems.
Although in that specific case, we can efficiently determine whether or not numbers are prime,
Right,
right? We
right,
just
right,
can't
right,
tell
right.
you the factors.
Yes, yeah. So in that, yeah, if the debater was able to respond like, oh well, this like primality test shows that it's composite, and like here's the proof of correctness for the primality test, then like, but then you have to know that like, so yeah, so then the problem is, what if the other debater says, oh well, like I know that there's a mistake in your primality test proof, correctness proof, I just like don't know where it is because the proof is really long.
Yeah.
Like if the proof is like obviously actually short, um that like in this case the proof is not going to be that long and it's going to be kind of obvious that like finding a mistake in the proof is a lot easier than finding the factors. But like this, you have this problem in general where both debaters can be like, oh, it's just like I know that there's a flaw in your argument, but it's computationally intractable for me to find the flaw, like that, which is why I can't show it.
Okay. And is that so? There's another post that you have on something that you call the obfuscated arguments problem. Is that basically the obfuscated arguments problem?
Yes, and so again, this thing about like some the optimal strategy sometimes being computationally intractable. It's like something that was in the original debate paper or whatever. The sort of
Yep.
claim we're making is, in fact, the dishonest debater can construct arguments such that finding the flaw in them is intractable, but
Hmm.
that they appear to support the dishonest answer. And these it's not easy to just show that these are weird sort of deliberately obfuscated arguments. And that you can do this. It doesn't have to look like some sort of cryptographic thing where you're asking for a known computationally intractable thing. It can just be like they just make a bunch of confusing claims about physics, and like the honest debater doesn't know which one in particular is wrong, and you can sort of keep supporting them with claims where where there has to be some mistake somewhere, but it's not clear where.
Okay. Yeah. I guess the question is, what do we do about this problem?
Yeah. So, I mean, to be clear, I think we haven't like robustly experimentally shown that you can in fact do this. Like I think we sort of, you know, came up with a bunch of these arguments, eyeballed them, and were like, yes, it seems like in general, if you practiced this, like you could be good at generating these ones, and particularly like, you know, maybe if it's some debates about like mechanics, I can be like, huh, that looks a bit fishy. I think, you know, aren't like energy arguments generally simpler than mechanical arguments or something. But, you know, if it was something about like quantum physics, I'd be like, I have no idea what like reasonable argument strategies are in this debate. I know nothing about. So yeah, what was I saying? Oh yeah, so yeah, I don't think we've like, you know, particularly firmly established this is true, or like established it in a way that other people should necessarily believe. But I kind of feel pessimistic about it or something. Um,
Okay.
yeah, so I think, in fact, like where I am currently at is like this does make debate significantly less powerful than we were hoping, and we need uh we're gonna need like another piece in order to know everything the model knows. And in particular, kind of like I was saying before, like you have this problem of, you know, say your model knows something, and like the reason why it knows it is like it had some heuristic that was reasonable a priori, and like all over training, like that heuristic worked well, and you know was gradually uh upregulated. That's not the right word, but you know, and like now it just like has that as a kind of intuition. It's like, how are you going to justify that in a debate? Like, well, technically, or, or like the sort of classic debate approach is like, what the debate is like, I don't know, it worked this well on the first half of the training data and this well on the second half of the training data, and like, you know, if one of those is wrong, challenge it.
Hmm.
But in practice, like the debaters, like that, this is another one of those like computationally intractable things. Like the debaters aren't going to remember exactly how well it did on exactly which bits of the training data. Like they're going to have thrown all that information away if they're being like reasonably efficient. Um, like it's completely unreasonable to expect them to like, you know, do optimal play on this debate about how exactly well did this heuristic do on like all of the data points you've ever seen. So yeah, we're gonna need some way of verifying those kinds of claims that is like less unreasonably demanding of our debaters.
Okay. So is the research strategy like think of types of claims that debate maybe can't deal with, and then like come up with protocols for that?
Yeah, that's a lot of what. So yeah, the kind of earlier work I was doing was, you know, figuring out how to set up these experiments and like what a reasonable debate protocol would look like, and then being like, okay, we tried these debates, they like didn't work for this reason, can we tweak the mechanism to fix it? There's a kind of, you know, there's a branch between like, is there something we can fix with the tweak of the mechanism, or is this a kind of fundamental problem? And we ended up on it, you know, there are a bunch of things like the ambiguity, or like not focusing on the right thing, that we think we just fixed by changing the mechanism, and then this is something we think like can't, you know, this is like a class of things that can't be fixed by changing the mechanism, and that we're going to need some completely different approach to deal with. And this, but yeah, so Paul has some ideas in this direction, which has variously been known as learning the prior or imitative generalization.
Cool. So I'm going to talk about that, but a bit later. I still have more questions about
Okay.
debate. So one thing I noticed is that like it seems like, so this question has a specific and a general version. Here's the specific version. The thing you mentioned about like sometimes your reason for believing something is like, well, it's just a heuristic that worked well in my experience, and like it did pretty well, and no other heuristic did better. And like I think that comes up with human arguments, right? Like I
Mm-hmm.
sort of have this sense that like sometimes that's when my dad is telling me something, right? Like that's his reason. And in general, the task of like coming up with like ways of structuring debate that promote the truth seems pretty relevant to humans that want to use discourse to discover the truth, right? So I'm wondering, in both in that case and in general, to what extent do you think like thinking about debate has like in this AI context has helped you think about like, okay, as humans who are trying to like have rational discourse or something, how can we like structure that well?
Yeah, I think I haven't in fact thought about this like that much. I guess particularly because once we're getting towards these more exotic things involving like making copies of people and all that kind of thing, it's like not very practical or something.
Not yet.
Yes, indeed. I think, and I think the other thing is like, yeah, in fact, all this stuff that like can only be justified by intuition and things like, yeah, I think actually in human debate, you do get this thing of like a lot of things that come up in human debate are just yeah based on intuitions or like it's opaque to the human why they know it.
Hmm.
And I think there's some yeah so some of this is like a fundamental problem that's shared with ML debate. I think you might hope that in ML debate you can do better because these models are being trained to reason in a way that's transparent to them and to humans.
How are they being trained that way?
As in because that's what debate incentivizes. Like it incentivizes being able to explain your reasoning in a convincing way. So like maybe there's various adaptations where humans just like throw away the reasoning like once they're done with it, or like it might be relatively easy for our cognition to be more transparent to us, but it just like happens not to be because that like hasn't happened to be particularly useful. But if we were being optimized for that, like it might be better. But yeah, so I think there is definitely interesting stuff here, and I think that the idea of yeah making it clear how your argument splits up into parts, and then having some kind of mechanism where you choose which part to focus on that makes use of the fact that the people doing the debate might have more idea of like which part is productive to focus on than the listener is good. But I guess there's also another difference, which is like if you're thinking about like how to have truth conducive debates between people who are already kind of trying to be truth conducive and trying to reach agreement, like you don't need these mechanisms so much. And in places where people aren't trying to be truth conducive, you're not going to get them to be able to you're not going to be able to get them to agree to use the mechanism. If for political debates or something, if you're like, yes, we think that if you like instead of having a televised debate where you just talk at each other, you will like play this do this like game uh this interaction with all these rules that like uh and people some panel of judges will judge all the individual parts of it, and then there'll be an answer about who's a winner. Like it's like probably people aren't going to want to do that. And yeah, and I guess the other thing is like the other reason why it would be hard in that context is I think like I said before, an individual debate is not at least how we've been thinking of it, an individual debate transcript should not necessarily be convincing to the judge. Like it's only convincing if you like assume optimal play everywhere else. So it's not like you see this transcript and you read the argument and you're like, oh, I understand, I like see why this answer is correct. You're like, okay, if I assumed that like all the unchallenged answers were in fact correct, then I see that like this thing's correct.
Okay. Yeah, I mean, I guess like so in terms of the like political example, or the question of like, well, you're assuming that you have like it's only useful if one of the players is like not trying to be honest. I guess it could be the case that there are some contexts where like you have participants in a discussion, and like not all of them are trying to be honest, but they're trying to appear that they're trying to be honest.
Mm-hmm.
Like like it seems like that should come up at least sometimes in human
Yeah,
discussion, right? You'd hope.
yeah, I think that's right. Yeah, and again, hopefully, I guess that the context in which it should be most useful is if you have like, you have several experts who disagree, and
Hmm.
maybe one of them, some of them are being dishonest or a kind of fraud, and you don't know anything about the field, and but you do really want you just want to know the true answer, and you have some control over how I don't know they're like competing to for your you want to pay one of them to do something for you, and you want to
Yep.
figure out who's actually good or who's actually correct, and then you can say to them, like, instead of just having a discussion in front of me, I want you to like play this game.
Okay. So sort of related to this. Yeah, so one question I have is, it seems that a key feature of the debate structure is that you have these like very unambiguous claims that are like either definitely true or definitely false. And it's both the case that like that's what you're debating, and it's the case that that those are sort of the subclaims being brought up. I'm wondering, do you think this covers much of the space of what we're going to know from models? What we're going to want to know from big advanced machine learning models? And do you worry that it's going to make it hard to discuss things that you only partially understand, but you can still make valid arguments about? I guess this might be the same thing as the heuristic thing.
I think this is. I think there are some different things to say about this. And this isn't exactly what you're asking, but I think in fact we ran into some trouble with having like the sort of, we were thinking about it being like the debaters make claims and those claims are either true or false, just because in fact like true or false is kind of actually like not that clearly defined. Or like the classic example being like, the king of France is bald. Like, is this claim true or false or not, given that like France doesn't have a king?
Seems false, right?
Well,
I mean, it's definitely not true, right?
but it's,
Maybe like the king of France does not have hair.
if you formalize it, it's kind of like, it's like exists king of France and king of France is bald or something, and it's well, I don't know, or like, anyway, this isn't always like as clear as you might hope. So we instead move to the framing as like, uh, there is a question, and the debaters give two answers, and what the judge is trying to say is like, is which is the better answer, or like, is one of these answers, or are they like sort of indistinguishable? Certainly if the debaters themselves only have kind of fuzzy knowledge, they can say like, this is probably something, but it might be this other thing, and that can be a better answer than some confident claim if like you can show that the confident claim is overconfident. I don't know if that answers your question. I guess a kind of related thing which you might have been asking about is just like, what, like, can you use this for claims that have like a moral component, or a component that's just about someone's personal preferences, not just about things that seem like objective facts about the world or something.
Okay, what if I ask that question?
Okay. So yeah, well, one thing is, actually once you start saying what is a better answer to this question, then it does end up kind of being about the judge's preferences, or like you end up getting into ethics pretty quickly or something, because it's like, well, what is it? Part of one of the debaters' arguments could be like this answer is better because it will like cause you to do more ethical things in the future. Like better ends up getting into ethics. Like, I think there's an interesting phenomenon that happens in policy debate. So this crazy thing that Americans do where they talk very fast. I yes, it's like, yeah, I guess high school or a university debate with a particular set of rules that has these very elaborate strategies, and yet also involves people talking at ridiculous speeds. And one of the things that tends to happen, and there's a term for it which I can't remember, like one of the debate teams chooses a strategy of saying like, not necessarily trying to argue that some answer is like factually true, but saying like that like the judges are ethically obliged to pick their team for some reason or something. Like, there was some example about something to do with I think there was some question where one of the debate team's answer was just like that it would be, policy debate would be perceived as more like fun and engaging if this answer was favored, and like policy debate being fun and engaging was like beneficial because it was beneficial to students in all these ways or something like that. So the debate ended up being much more about like appeals to the kind of morals of the judges and like the consequences on the world that them choosing one answer or another would have. So I think in some sense, like even if you try and avoid this, you're always going to like debate tends to kind of drift in that direction because it's like ultimately what you are trying to do is like persuade a judge to choose one action over another, and like where one action is picking one answer and the other action is picking the other. And like
Why couldn't you solve? I feel like listeners with a rationalist bent might be thinking, okay, why can't we just solve this by saying the way you judge debates is which answer corresponds more closely to reality?
I guess well then so then you're weighing like the rules against like you could still appeal to someone's like moral obligations or something, like suppose uh you're a contractor employed as a judge in some games, and you have a certain set of instructions to follow, but the debaters say like, oh, like if you pick this answer, some like bad thing will happen in the world, and they like persuade you of that. um like ultimately what if you're trying to make someone make a decision, and like what you're going to appeal to is their like the way they make decisions, which is sort of related to their ethics. And so yeah, so I think you can try and have rules to rule this out, but I also don't like think you don't actually want to, because like if you do that, then like what are you going to do about any claims that are any questions that are about like what should I do? You'd be like, oh well, your rationalist would say, well, that's like not a question that has a meaningful answer. There aren't answers that correspond more or less to reality or something.
Or I don't know, they're just I mean, one response would be that. Another response would be like, well, they're just like facts about what you should and shouldn't do, and like the way you should answer the question is to correspond well with the facts about what you should and shouldn't do.
Yeah. Um. Yeah, I don't know. It seems tricky. I think it's yeah, or at least where I'm currently at is like you have to accept that things are going to come down to like which like what are the consequences of me choosing this answer versus this answer. Like where okay, so here's another reason why that's difficult. Like something could correspond more closely to the facts but be like really unhelpful for some other question that you were trying to answer.
Maybe an example is so a fact about myself
Mm.
is that I was born in Australia and I was raised in Australia. I have an Australian citizenship, but I live in the United States. And probably the people who I am most similar to in the world, many of them, like a lot of them, are Americans. I sound kind of like an American, and so perhaps an example. You can tell me if this is wrong or not, but perhaps an example would be like you want to know you're asking a question. You want to figure out like part of my deal, like does Daniel live in America? And you ask, is Daniel an Australian?
Hmm.
And the answer is what like well yes, but that's not the important thing for what you like really care about. Is that like kind of a weird example, but is that an example?
Yeah, I guess the more general claim is just like what is a good answer to this question like depends on the context in which it's being asked. It doesn't like yeah.
And even formally, like I don't know, closeness, like degree of closeness of correspondence to reality, sort of like depends on some metric, right?
Yeah, like I don't know, if you asked some question, say you're like, I don't know, am I sitting still or something, it's like, well, I don't know, yet like in some mundane sense you are, and in some other mundane, in some other sense, I'm like moving through space really fast, and in some other sense, like, oh well, it just like that there isn't an answer to that question because it depends on the reference frame, like.
In some sense, I'm like twitching a tiny bit.
Right. So yeah, I think it's easier to follow a rule which is like, what is a better answer to that question, which includes, like, how will that question in context help you like make decisions and figure things out, rather than like, oh, does it like like technically correspond to reality, or something like that.
Okay, so I think I'd like to move on a little bit. So you mentioned that like one problem that debate has is it's bad at like revealing knowledge, which is or revealing facts that are sort of based on heuristics which have worked well in the past and we're going to apply now.
Mm-hmm.
And you mentioned that there was this approach called intuitive generalization that was maybe good for this. Could you talk about that?
Actually, I had one more thing to say about the like previous thing, if that's all right.
Yeah, definitely.
So, but on the subject of, you have some human who's been given some instructions and told to follow them, but like the debaters are just trying to persuade them to do one action over the other. I think there's definitely some concern for like when you actually run debate here. Like, I think in the experiments and sort of theoretical thinking we've been doing, we've basically been assuming like, oh, just assume the humans will just like correctly follow the instructions as written. But I think related to the thing of like, debaters like hacking humans or persuading them or something, I think there's something that's like, even if it's not like, I don't, they just like wrongly convince them of something, you might get something like they convince them to not follow the rules, and then like everything else breaks down. Yeah, I guess it's like we hope that debaters won't be able to sort of hack humans or convince them, because it's like, oh, they only have like, they can only make these relatively short utterances, and we're like doing all of these checks and stuff to make sure that any sort of suspicious kind of persuasive stuff doesn't get passed on. But if they can persuade the humans to like not follow the rules, then you're kind of in trouble or something. Like, one thing Evan and I were like thinking about as a kind of silly example is like, I don't know, your debater persuades sort of breaks the fourth wall type thing, and rather than like talking about the subject at hand, like tells the human that they'll like suffer horribly if they don't pick their answer or something like that. So I think there's something, yeah, we haven't thought much, and it's something that I think we're gonna need to think about more with lots of different alignment techniques. Is like, how does this actually work with real humans in practice, and like they're not going to follow the instructions perfectly, and they can be persuaded that like following the instructions is a bad idea.
Yeah, and that Evan is actually Evan Hubinger, who appeared on episode 4 of this podcast. So it all links together. Yeah, that was interesting. I think you mentioned that intuitive that there was some problem with like, well, you just have like some heuristic that works well, and that's why you believe a thing. Um, but it's sort of hard to like give an argument other than like, well, this heuristic has just worked really well. And I believe you've mentioned that there's this approach called intuitive generalization. That
Imitative generalization.
imitative.
Sorry. We've been through a lot of names and none of them are good. Sorry.
No, I think the problem is I was thinking of the word intuition and my handwriting is messy. But imitative generalization. Could you explain what that is?
Yeah. So I think the easiest framing to go at this from is like via debate, given that we've been talking about that already. So I think as I mentioned before, yeah, you can imagine, say, one debate is like, well, I just know that, I don't know, breaking down this problem in terms of this physics problem in terms of like conservation of energy is like more likely to get the right answer than this approach you're suggesting, where we break it down in terms of like all of the forces. And I don't have a like logical argument of why that's true. It just like, I don't know, I just did, I've tried a bunch of problems and that's what happened to work better. And the other debate is like, oh well, like, I don't believe you. I've tried a bunch of problems and the forces approach has worked better. And then it's like, well, how are the debaters supposed to justify that? And sort of like in standard debate approach, would be like, oh well, they can claim like it worked well in the first half of the examples and it worked well in the second half of the examples, and like if there's a if I'm lying, then you can challenge one of these, but like this is impractical. So what imitative generalization does is like, rather than having to go over every single training example every time one of these kinds of claims comes up, you just do like one pass over all your data and you get out an object that like captures all of that knowledge and is like a human, a sort of amplified human, so like a human amplified using IDA, or like a human like interacting with the debate is able to interact with that object and kind of use all of the information in it. So what this algorithm actually looks like, okay, first I'll say the version that like if you had like infinite, you know, as many humans as you wanted and you could use a bunch of their time, what you would just do is like have you search over some space of hypotheses, which are sort of like full kind of distributions of like sort of everything you think about how the world is. And for each of these, you ask, you know, you have your human supervised debate about what the prior probability of that hypothesis should be. And like for each data point in your training data, you have the human supervisor debate about what is the likelihood of that training data point given the hypothesis. So then, you know, like for each hypothesis, you've got a prior and likelihood score. So then you just, you know, you search over all of the, or, you know, as many as possible of the hypotheses in your distribution until you find the best ones. And this isn't intended to be like a like map, a like point estimate. This is intended to give you like a just like the best distribution. But yeah, obviously, in fact, we can't.
And here the hypotheses are like you said, there are these like ways of reasoning about like how everything will pan out.
Yeah. So like concretely, but impractically, you could think of them as just like a very long text that like explains, I don't know, a bunch of just sort of like rules for how to think about things, or like ways the world is, or like so I don't know, it could be like various physical constants and laws of physics and like principles that are useful for understanding history and, you know, things like this that don't have like any explanation behind them but are just like what fits the data. Yeah. So and then yeah, if you imagine this like giant, you know, giant wall of text, obviously that's like it's too long for the human to read and engage with all of it, so that's why you have something like debate, you know. So like for any given hypothesis, you know, you'd have one debater is like, oh, like this part should like mean the prior is lower because like this is unreasonable for this reason, or something like that.
So you told us how we could kind of do this if you have like as many humans as you want with as much time as you want.
Yeah, I realized I actually sort of already that is not in fact what exactly I gave you, because once we've introduced debate, we can say the same things we said about debate before, which is one thing I said before is like you don't in fact have to use the human every time. You can just train a reward model from the human and then do your debates against that reward model. And the other thing is like once you've trained your debaters, you don't have to do whole debates. You just like ask them to answer. You make them think they're about to do a debate. You ask them for an answer, and they give like the sort of answer that they could support in a debate, which like, you know, is hopefully truthful. So in fact, yeah, because I introduced debate already, which so you don't actually need
Yeah, but that still features like it still seems like you're doing this process over every like big long string of big long wall of text, right? And there are lots of big
yes.
possible treatises.
So yeah, there are a lot of difficulties with this. Yeah, so to be clear, this is not like I don't think we have anything in mind here that like actually seems like it would work. It just seems like the right sort of direction, or like you can describe versions of it that are completely impractical that like would sort of do the right thing. Yeah, and so to make this practical, you'd have to have some way, like reasonable way to represent these hypotheses such that the humans can still like interact with them, but they're like feasible to optimize or feasible to like explore the space. So you might also want to do something like you have humans demonstrate like modifying the hypothesis to make it more likely or modifying it to make it support the data better, and then have like train your ML to imitate that human exploration process. Yeah, there's various other things you could fiddle around doing with trying to make this actually tractable, and it's not clear whether whether that'll all work out or whether one of the modifications that you'd need to make will actually break everything. And yeah, and the sort of core hard problem does seem to be something about like how do you represent something that is sort of competitive with representing it as a big neural net in terms of like ease of optimization, but still has this property where like the human can actually engage with it and like understand what it means.
Yeah. So is the idea that as the human, if it's not if somebody's saying like, oh, here's a heuristic that I've learned that has worked really well in the past and it's going to serve me well in the future, and it says this, is the idea that like the human's going to check like, oh, that's actually a crazy heuristic, or like, oh, that doesn't really support what you say it supports, or oh, that didn't really work well in the past, and like in a way that like we couldn't just do mechanistically.
um I guess I'm not quite sure what your question is, but
Yeah, what's I guess the question is, what's the benefit of this over just machine learning?
so yeah, the other way to approach like why you would need this is basically like machine learning generalization is kind of scary. Like we have no particular reason to believe that that sort of implicit in ML architectures is a good prior, and in particular the worry is something that performs really well on your training data is an agent that reasons about the process it's embedded in and reasons about how to get a high score on the training data, and then like who knows what that does later on. And like we think there's like not that good a reason to believe that the ML prior would favor something that's sort of sort of directly a model of the world that will continue giving you sensible answers and is doing what you expect over something that's reasoning about the training process, especially because like if you ever have mistakes or quirks in your training data, you're going to favor the thing that's like an agent reasoning about the training process because it'll get those things right versus something that's like trying to be an honest model of the world because it'll get those things wrong. And in particular, like we're always going to have to do this generalization between questions that we know the answers to, or like questions that we can sort of produce training data for, versus like questions that we can't supervise at all. So the way something like imitative generalization is helping with this is like you are using the human prior rather than the neural net prior. So you only ever use ML generalization for things that are basically in the same distribution, or like you can check all of your ML generalizations, and the sort of uncheckable generalization is human. That is a kind of is informed by the human prior. This is kind of hard. It's confusing to explain. Sorry. Yeah. Okay. So just to give a sense of the like algorithm, I think this doesn't really give a sense of why it's useful, but just like, or not that much anyway, to give a sense of the algorithm and why it sort of helps with generalization. Imagine that you're doing every ML researcher's favorite task, which is labeling pictures of dogs. Um, so and you have some training set that's a bunch of breeds of dogs that are labeled, and a test set where you don't have any labels, but you want to label the dogs correctly. And further, imagine that you have various human contractors, but they don't know anything about dog breeds, and for whatever reason there aren't any books or things to learn about dog breeds. Like all you have is just like this one labeled training set. The standard ML approach is just like train your model on the training set and then just run it on the test set and hope for the best. But we know that like there are various things about the ML prior that make it can make this go wrong. For example, if in your training set, all of your pictures of huskies were on a snowy background. Like maybe if in your test set there's a picture of husky on grass, your model thinks it's not the husky. So like you could think about this as like your neural net prior doesn't favor the hypothesis. Husky is a big fluffy dog that's kind of like a wolf, over like a husky is an image with a lot of white and blue pixels, being like has a lot of snow in it. So the imitative generalization, what imitative generalization would do here is, so your hypothesis space is a sort of instruction book about how to label the images, which might be like which could contain different possible instructions, like if there is snow, label it as husky, or like if the dog is grey and fluffy with pointy ears and kind of wolf-like, label it as husky.
Okay. And really the hypothesis space is like any of these books is one hypothesis. And the space is like all of the possible books.
Yes. So yeah, all of the possible sort of instruction sets for like what dog breeds look like. So so then you give these instructions to your humans and get them to label the dogs in the training set and see how well they do. And you optimize the instructions to make the humans do well at labeling the dogs, where what the correct label is. But important. So, but this wouldn't give you a distinction between, the reasonable description of the husky and the description of the husky as like an image with snow. Like where you get that is you also give these instructions to the humans and ask them to say like a priori whether this is reasonable. And like for the purposes of the example, we assume that humans like vaguely know what animals and dogs are, but like don't know specific dog breeds. So then the humans would say that like basically they'd favor any description of husky which is like about characteristics of a dog as more likely than the description that a husky is an image with lots of snow in it. So then you optimize the guidebook. Hopefully you get one that has like sensible and correct descriptions of how to label all of the dogs, and then you can you give that to the humans and have them label your test set, and then you train your ML model to imitate the result of the humans labeling the test set. And now you can make like arbitrary predictions on your test set, and you can always check them with the humans if you want. And you have like on distribution labels for the task you're going to do.
Like once you kind of move to like you've moved to a new distribution, and then you like get human labels on that distribution, and you can sort of generalize from the human labels that were generated from learning on the previous thing.
Yes. Yeah.
So bringing that back to the debate context, right? So imagine that am I right that one example of where you might want to use this is like one debater says it's going to be like easier and better to use a breakdown of like the energies in this problem to like solve this physics thing.
Yeah.
Another debater says it's actually going to be easier and better to like do the breakdown of the forces. Is the idea that like using imitative generalization, like the reason that's going to be good is that we're going to have a good prior over, like a good human prior over which one of those is like better?
It's not like the reason this is hard in debate is partly just because it's sort of intractable to do within a debate. Like you could still imagine having a debate about like whether this is a plausible, like whether using an argument based on forces is better a priori, or using an argument based on energy conservation is better a priori. So the difference from debate isn't necessarily about the priori, but the difference from kind of like standard ML is about, and the difference from debate is just that it's like more efficient and more of a kind of reasonable setup. So like
okay,
if you did the IG thing with debate, instead of every time you have a question that relates to something that's justified by intuition from a lot of data, instead of having to go over your data again, you just look at the hypothesis that IG produced, and it's like, what does this say about that? So so in this case, you like look at the object you got out and be like, what does it say about when you should use arguments, but for what sort of physics questions are arguments based on forces like more likely to give the correct answer than arguments based on energy.
Okay, so you would sort of augment debate with like we're gonna use imitative generalization, just like on the side on like a ton of stuff, and we're gonna use that to inform like some kind of heuristic questions.
Yeah, I guess I usually, in fact, more think of it as like using debate on top of imitative generalization, as in like then
As opposed to the other way around.
yeah, I don't think it matters that much, but like what think of is like you get this objective out of imitative generalization that encodes like everything a reasonable ML model could have learned from this data set, and that's like interpretable to humans and like is a reasonable sort of model. It's not like an agent that's just trying to tell you the right thing. Sorry, trying to tell you what you want to hear. And then you can have debates that bottom out either in some like sort of reasoning of like, well, this implies that, or they bottom out in like, well, stuff we learned from data says this.
Okay. And am I right in thinking that this is sort of like a line of work to like make something like imitative generalization work, or is it like, nah, we basically know what it's going to look like?
Oh yeah, I think we really like don't know if I think Paul is vaguely optimistic that something will work, but it definitely doesn't feel like we have something like sort of reasonable yet. And I think so. I can say a bit more about like the difficulties and what I think the sort of hardcore is.
Yeah, I mean, it seems like two that jump out are like, it seems like there are a lot of long treatises that you have to deal with, and like the, in my head that was two difficulties, but I guess that's just one.
Yeah. So I think like one other way to see why this is kind of tricky is you're like, well, maybe one hypothesis that does really well on the training set is just like, oh, just copy the output of this big neural net.
Yep.
It's like, well, that does great. It gets all the answers right. But then we're just back in the same place as before, as we've just got to trust this. When we run that on the test set, will it give us reasonable answers? We have no idea. So you
Hmm.
need the human prior to like downweight, just believe this big neural network. But then I don't know, it's kind of like unclear. So we want something like, if there is any sort of additional structure that could be pulled out of that neural net and exposed to the human, a hypothesis that instead does that will beat the one that's like just trust this big black box thing, which seems sort of doable, but it's just like very confusing. How do you represent things in a way that like gives the opportunity for that, but we also like, if you imagine representing like everything that AlphaFold knows in text, it's like that's just going to be horribly inefficient to try and like optimize that and get the humans to do it, and also the humans going to have like no idea what's going on.
Yeah.
How do you represent that in such a way that the human has meaningful understanding and it's like reasonably efficient? And this I think ends up being pretty close to the sort of hard problems of interpretability, and like Chris Oller's ideas about microscope AI feel like the kind of original statement of this sort of problem, or like what we want to do, where so Chris says like, one way to have sort of capabilities of AI safely is like if we're able to do sufficiently good interpretability that we just look inside the model and we like see all the things that it knows, like all of the things it's sort of extracted and understood from the world, and then we can just use that knowledge to do stuff that we think is important. And the obviously difficulty is there. It's like how are we going to understand like what is the model knows, or like how are we going to come up with interpretability techniques that turn like the gazillion weights into like, now I have this insight about the world. And like one way you could imagine setting up ID and like the imitative generalization, and the way you could represent the hypotheses is like your hypothesis is like a neural net with a bunch of annotations, and you optimize the neural net and like the weights and the annotations jointly, such that that combination of weights and annotations is plausible to the human. And when the human sort of when the human assumes that the annotations and the net are correct, they use it to make good predictions. And this is this then ends up looking quite a lot like sort of you train a model for interpretability, and like your kind of standard for like whether something is a correct interpretation of what the model knows is like, does it cause the human to get correct answers on the training set? And how you imagine so you can imagine something going on with the annotations looking a bit like, the like circuits that Chris Oller and co have kind of produced for models we have now, which is like, the human would look at this annotation and I don't know, so in the Husky case, they'd see like, oh, here's the bit that's a fur detector, and this feeds into this like pointy ear detector, and here's the fur detector and the curved line detector, which detects, a tail or something. And if they saw that the Husky detector didn't use any of those features and just use a snow detector, they'd think like that was suspicious, and like that isn't how it should be structured. And like, and the reason you'd think that the annotations you end up with when you optimize sort of do correctly reflect the knowledge is like, well, if you've labeled something as a pointy ear detector versus a floppy ear detector, but it's actually a boat detector versus an aeroplane detector or something, like this will not make your humans get the right answer when they're trying to label dogs.
Okay. I guess that actually gets to another question I had. Suppose it's the case that you're a listener, right? So some listeners to this is thinking like, man, this line of work is pretty exciting, I'm pretty pumped for it, but like for whatever reason, this listener thinks like, well, I don't want to do it directly. I don't think that's something that's for me. But maybe there are like complements. Like there are things that like people could do that like aren't exactly working on this, but that are like really useful for working on this. Yeah, I'm wondering, what do you think the complements of your work are?
Yeah. To be clear, I'm not exactly working on this either. I'm currently just doing miscellaneous stuff, but yes, yes, yes. Really excited about people just doing a bunch more interpretability. There are a bunch of benefits to this and like several different ways it ties into both this stuff in particular and just like AI safety in general. So yeah, like I guess as I was saying, it seems like particularly sort of Chris Olah style microscope AI type interpretability is like trying to solve the same like more specific problem that we're kind of running into here. Yeah, they're focusing on the same thing of like how do we represent like knowledge in a way that a human, like maybe like, an assisted human, like in the case, either assisted with debate and whatever interpretability tools we can build, and just whatever else we can build that's helpful to the human. Yeah, how, like such that they can actually engage with stuff the model knows. And I think more broadly, I am just excited about more interpretability. So I think that like on the margin, or more just doing more interpretability and raising the bar or the kind of expectation of how much we understand our models before we deploy them and do stuff with them would be really good, because I think it's just going to be, yeah, every bit more that we know about our models and have some insight into what they're doing is going to be helpful to safety. I think, that I guess sometimes I think about that there's some kind of like window for sort of treacherous turn where there's the time between when a model is smart enough to think about deception and when it's good enough to get away with it. And like, if the more interpretability you do, the widen the, yeah, you increase your probability that you'll be able to see that your model is thinking about this kind of things, or considering doing things you don't like, rather than like having to see it actually happen in practice or something, which pushes out like it's going to be a lot harder to make it invisible that you're thinking about deception, as opposed to just like, I don't know, like avoid like trying to take over stuff, or like avoid behaving in a way that's obviously bad. I guess also, so yeah, so there's the way this ties into the sort of pool style alignment, where we want to have a story of really how we're going to know everything the model knows. And I think even if you think that's just like way too demanding and we're never going to be able to do anything like that, it's still useful to have a bit more interpretability. Like, even if we can just do very crude things like, is this model just like thinking about some category of stuff it really shouldn't be thinking about? Or like, is this structured in a way that suggests we've sort of got an agent, or it's doing a bunch of search and planning where we're like, not, that wasn't what we wanted? Or even like, we know we've got something that's like an agent and we want to try and take sort of parts of it that we can use without like using the whole agent? Can we sort of figure out which bits of the world model and which are the agent, and do some very like crude kind of lobotomy model surgery? Like I just think even having like a vague idea of which bits are doing what, like I think it's kind of, this idea is due to Rich Ngo, by the way. Like it is interesting that in humans, in fact, it does seem like frontal lobe lobotomies actually do the thing of like mostly removing agency and mostly preserving world knowledge. I think I like don't know very much about this and would be interested in someone looking into that more, in particular whether lobotomy patients who are extremely passive can still like model or understand the sort of agency or actions of others. That is very much a tangent. But anyway, so one of the things I'm excited about is interpretability for various reasons, but I think it also particularly ties close to this. Or other things I'm excited about people doing. I am excited about people just generally building more of the infrastructure for having these very human in the loop training procedures. So like, you know, if we are gonna want something where we have a large number of humans who are like carefully and correctly following some like moderately complicated instructions, and like we need them to make good judgments, and we maybe also need them to be like reflective of broad values in some like reasonable sense. Like what are all the logistical challenges of doing that? Like you could do several iterations of like trying to get humans to follow instructions while they interact with something that tries to persuade them not to, or something like that. It's like, what do you have to do to be confident that your humans will actually follow the instructions you've given? Or, you know, how are you going to set up sort of layers of oversight and monitoring such that you can make sure your large number of humans are doing the correct thing? Something else I've been thinking about recently is like, yeah, how does this work if you want, you know, your sort of humans, or your, like, you know, in the debate example would be like the debate judges, to sort of reflect broad values. How would you do that, and how much convergence is there between people who have different sort of object level ideas about morality? Do they agree more about higher level principles, like, you know, what is good reasoning about ethics, or like who are the right sort of people to trust, or like, you know, what are the sort of things you do to get a better answer to an ethical question? I feel like this is something maybe people who think about sort of coherent extrapolated volition or things like that sort of assume that people, you know, pretty widely agree that, you know, this is sort of like you will make a better ethical decision if you've like thought about it for longer and have more information or something. But I'm actually like not quite so sure whether that's like true across all cultures, or whether people, you know, would say something like, oh, it's like more, a decision is like more valuable if you do it just based on faith or something, or like, you know, the first thing you should do is like to lock in your like faith and make sure you don't get like corrupted or tempted away from it by arguments. On the other hand, I think it could be useful for reducing kind of races, or you know, a sense of people, you know, wanting their side to develop AGI first, if we can show that people in fact do converge and agree a lot, or if you can construct some kind of example system that it's like, here is this thing that kind of works and does seem like there are a bunch of ways people can sort of converge, and like that it would reasonably represent like everyone's interests in a way they're happy with.
Okay, cool.
Yeah, so I feel like the kind of obfuscated argument post is just like, you know, we kind of took that work to a point where we eyeballed it and were like, okay, yeah, we're sufficiently convinced that this is a limitation that we're going to like move on to some other things. But I think it's really not very solid. It would be really nice for someone to both like try to experimentally validate that like obfuscated arguments exist by and that, you know, that people can't distinguish obfuscated decompositions from honest decompositions, and try that. Although I do think like a negative result with humans might not be that convincing, because it seems like, you know, maybe humans are bad at coming up with obfuscated arguments because that's like not usually how they think, but if you train a model to do debate, they'll get really good at coming up with obfuscated arguments. But anyway, I think it would be worth investigating that a bit more. And I also think there's some like theoretical CS proofs that turned out to be a bit of a headache. About Mellanoth protocols being equivalent to the former version of debate in the certain setup that I wish I had been able to do well, but kind of gave up on. But I can imagine someone who had the right background might be able to just like do that much more nicely. Because I think we're still not quite sure whether we've got all of that right or something. It's like relatively straightforward in the case where we're just talking about like, oh, there's like a big argument tree. The argument is all conjunctive, and like the question is whether there's a flaw somewhere, and then if the debaters have no idea where the flaw is, it's like relatively obvious there that like you could have a different protocol which is just like you only have one model and you just have your other model just like randomly chooses which branch to take, such that if your previous model was only choosing randomly anyway, then like those are obviously equivalent. But when you have things like the the argument isn't actually conjunctive, it's like parts of it are disjunctive, it's like a bit less clear what the sort of like simple equivalent is. And
Okay.
there's like lots of stuff there for people who would be interested in thinking about that.
So in terms of this like general approach, so I sort of see as it is saying like, okay, we're going to come up with like debate. We're going to find some flaws with debate. We're going to come up with a new thing to fix the flaws. So there's imitative generalization, which is like an idea for like fixing one of the flaws. How many other fixes do you think there are left that like need to be come up with?
There's like kind of a few different categories of things. There's like the thing I was talking about before, which is like actually getting the logistics of all of this training process set up and making sure that humans are doing what you expect them to do is like a whole thing. Like that's gonna be tricky. And there's various like sort of tweaks to the mechanism and like the structure to sort of make it better. I know maybe I'm being like overconfident and too inside viewy here. It does feel like maybe there aren't additional problems that are sort of as big and of a similar type to this like knowledge that's only justified via intuition. Like it feels plausible that the pieces of like IDA/debate plus imitative generalization like capture all of the kind of ways of knowing things. But like there could easily be something else. I'm not that confident. It doesn't feel like there are going to be like loads more pieces of that size. I think. I guess something else that I'll just say here because I haven't mentioned it yet, and it's maybe kind of important. It's just like I and like Paul, I think mostly don't think that we will actually use debate to train ML systems, and that the reason that it's worth thinking about, at least for me, it's just like easier to understand and think about, and like it's a lot more practical to do human experiments with than IDA, but like has basically the same set of limitations, and I think that's kind of an analogy that like if there is a winning dishonest strategy in debate, that corresponds to like a problem that you might have in IDA, and like if there is no winning dishonest or no drawing dishonest strategy in debate, then like your IDA should work alright. So imagining that what we're actually gonna do, looks a lot more like amplification, but we're just like thinking about things in terms of debate. I think, for what it's worth, Jeffrey Irving, who's the actual original like creator of debate, maybe thinks more that we will actually do something that looks more like debate, and doesn't see it as just being. I mean, he definitely sees it as like analogous to IDA, and that's how he came up with it while he was trying to understand IDA. I think.
I'm not sure if we've explained exactly what IDA is in general, but now that we've said that that's the thing we're actually going to do, what is IDA and what does it stand for again?
Yeah, so it stands for Iterated Distillation and Amplification. So I think I mentioned HCH before. So this is the idea like one way you might like solve a problem or answer a question or sort of like have like a more formalized model of like humans sort of thinking for a long time, or humans doing all the cognition they can.
Mm.
Is having humans who give subtasks to other humans and then use the results of those subtasks to answer, solve part of their own task and pass that on.
Yep.
So IDA is like a proposal for approximately how to sort of tractably train an ML system that gives the same results as this HCH tree. So with IDA, like one way you can think about it is like first you train a model that just imitates the human doing some tasks. So you have the human do a range of tasks, you train a model to imitate that. Fine, relatively safe. Then you have the human do tasks using that model to help them do subtasks. So this is now a sort of like depth 2 tree where you have the human and then they send queries to this model. So now you can train another model to imitate that. So you're training a model to imitate a depth 2 tree, and that little tree can hopefully do more than like a human alone could do, because the human's able to ask this other model for help.
Gotcha. So and how is what's distillation and amplification? I can sort of see what's being iterated here.
So the amplification step is when you give the model to the human to like assist them, or like amplify their abilities to do stuff. And the distillation step is when you train a model to imitate that like team of humans and models.
Okay, so the thought is like that's what we're actually going to do, and all these experiments about debate are just sort of to inform us on how well that works. It seemed like the detailed rules were pretty important in debate. I'm wondering like do you think that's how are we going to transfer that knowledge to doing this IDA protocol?
I think that there's some way in which it's like, oh yeah, the rules are basically totally irrelevant. They were just like us figuring out which things are sort of like real problems and which things are like deep problems and which things are kind of contingent problems. So like we find a problem, we fiddle around, we fix the rules, and then eventually we find a problem that like we can't seem to fix by fiddling with any of the rules, and then we think about it and we're like, yes, this is like a deep problem for both things. But I think parts of the parts of the ideas and rules will still apply. Actually, this is my sense of humor is actually not something I've thought about in that much detail, I guess, because I've either been in the space of like, okay, let's just try and make debate work concretely, or been in the space of like, okay, let's think about the like deep problems and how they relate to each other. I don't know, it feels like we're generally learning useful things or something. But yeah, I'm not actually sure that there'd be like a direct, like that many direct analogies between like this particular rule set and like stuff we do in IDA. I don't know. There's also various ways you can kind of like blend debate and IDA. So like, for example, if instead of training your model to imitate this little tree, you could train your model to maximize the reward given by this little tree. So like your model like does some stuff, gives some answers, and then the human, with the assistance of like a previous version of that model, assesses how good the answers and things were. So you can imagine something that's half and half. It's like you have a little debate, and then the debate is judged by like the amplified human or something like that. So yeah, there's sort of a continuum between these. You can kind of interleave them.
Okay, and one thing I'm just realizing that might be closely related to that is it seems to me like I think at the start we were like, yeah, the point of debate is that we have a machine learning system and it knows some stuff, and we want to know, like, if we have a question and it knows the answer, we want to know what answer it knows. Whereas IDA to me sounds like the problem of like I'm a human, I want to like solve some tasks. Like it has kind of a different flavor. Is the idea that like when we're doing IDA, we're doing it on like the humans trying to figure something out about a model, or how can you say more about that correspondence?
Yeah. So yeah, you can totally imagine that the top level question in IDA is like, this model has suggested this plan. Is this suspicious and dodgy, or is it a good plan? Like, say it's same as debate. There's a sort of, you can kind of move between like planning and actions in the world and just language and question answering. If you can do questions about whether something is a good plan, or whether some model should be trusted to take some sequence of actions, or whatever. In that case, with IDA, we want it to be able to answer every we have some model and we're trying to get it to do things, and we also want it to tell us correct answers to questions. And the way we know that it's telling us correct answers is that we've trained it to imitate like the answers that humans get after they think about it and pass off all these subtasks and aggregate all these subtasks. So like I said before, maybe you'd have a debate about whether some model is going to be deceptive, and one debater would point out that like this part of the plan would have like this consequence, and this would involve the model getting lots of power, and this would be bad. similarly, the sort of IDA equivalent is like the sort of implicit sort of equivalent HCH tree would be like a bunch of humans being like, okay, well, like, is this part of the plan reasonable? Is this part of the plan reasonable? Like, what are the possible consequences of this action? What are the possible consequences of this other thing that's going to happen? And eventually you get some answer that's like, yes, at step 20 when this lever is pressed, this happens, and then something. Yeah, I mean, I don't know. Sometimes I worry. I personally sort of play too fast and loose with, everything's analogous to everything else, and you can move between them. And maybe I'm missing out on some details that are important. But I do tend to think of like you can turn lots of these things into other things.
So, I guess my last question on this type of work. So, as you might know, in NeurIPS, they recently required broader impact statements. And in particular, they asked people to imagine, like, okay, the work you're doing, what are possible ways that it could turn out to be bad? And I kind of like this question. I think people working in the AI X risk space rarely ask it of themselves. So, if all this work on debate and imitative generalization, if this line of work turned out to have like negative consequences, and they don't get to be like, oh, it didn't pan out, so there was an opportunity cost. Something bad happens
Yeah.
because this research. Yeah, what's the bad thing?
Okay, there's a few different things I can come up with here. Like, one is something like stuff is all kind of like looking like it's good in sort of like theory land and in human experiments land, but like in fact it just is kind of impractical, and like what we should have been thinking about the whole time was more sort of in the weeds hacking together ML stuff to like be sort of incrementally more aligned and like patching various problems, and like we're sitting here in our ivory tower speculating about how we can know everything the model knows, and in fact like we should have been just like, oh, is there some trick we can use that like makes it a bit more likely that we'll catch things of this type. I guess there's also something else, like maybe it's not exactly that's the problem, it's just the fact that there's some fundamental flaw with things like debate, and it like all looks like it's working. We're like, great, we'll use it to build the aligned AGI, and then it turns out it's actually not, and it's all terrible. I don't know if there's I mean, I could go on brainstorming. There's probably things related to like maybe alignment isn't the only framing that's the like important part of risk, and looking like you have more of a solution to alignment makes people more excited to build powerful AI, and then like there's some like not quite alignment related thing that goes badly that like I don't know, something about like misuse or something that people would have been less likely to do if no one had been saying like, oh, we think we have a relatively good alignment solution. If everyone's like, oh yeah, just like whenever you try to build a powerful model, it just like this will always backfire on you or something. Maybe this is actually a better world if people believe that. I don't know. This is pretty speculative. I don't really believe that.
That's fair enough. Yeah. So closing out, you mentioned that you were no longer working on at least debate stuff, and maybe you said you weren't working on imitative generalization. What are you doing these days?
I'm trying to figure out what exactly I should be doing. Currently, I'm sort of being a sort of miscellaneous safety strategy person at OpenAI and writing a lot of Google Docs and like gently doing a little bit of ML experiments that are kind of related to imitative generalization. Yeah, not quite sure what I'll be doing in the future.
Sure. If people are interested in following you or your research or exciting things you're putting out, how should they do that?
Yeah, most of the things will probably be alignment forum posts.
All right. Well, thanks for appearing on the show, and to the listeners, I hope you join us again.
Thanks for having me.
This episode was edited by Finnan Adamson.